Refraction and Snell's Law, a 9th grade conceptual physics video. Yet another way of thinking about the behavior of light is to compare it to the behavior of a phalanx of soldiers who are marching at an angle across hard ground. They are about to march into the mud. When each individual hits the mud, they slow down because they cannot move as fast in the mud. This causes the line to mess up as more and more people hit the mud. If you draw arrows that follow the path of the marchers, the line refracts the same way light would refract, going into a slower medium and bending towards the normal. Let's go back to the laser tank lab to help us get to an equation for refraction. We know the triangles are not similar, the angles are not the same, but the ratios of the triangles are still going to help us. We need to look at the ratio between two sides of the triangle in water and two sides of the triangle in air. It's going to be difficult to talk about the sides without some names. We are interested ultimately in talking about the angles. The sides of a right triangle are defined in relation to the angle you are interested in. So let us look at the air triangle in relation to the angle of incidence. You already know which side is called the hypotenuse. It's the longest side of a right triangle. We will label the hypotenuse with an H. The other side that touches the angle, the one next to it, is called the adjacent side. Adjacent means next to. The final side is the one on the opposite side of the triangle from the angle. That one is called the opposite side, O. In your data chart for the laser tank lab, you calculated every hypotenuse and calculated the ratio of the opposite to H, distance in air over hypotenuse in air, for each trial. You also calculated the ratio of O to H, distance in water over hypotenuse in water, for each trial. If we test them, those ratios should not be equal. Opposite air over hypotenuse in air does not equal opposite in water over hypotenuse in water. However, we found that if we calculate the ratio of ratios, we get a nearly constant number for each trial, around 1.3. This nearly constant number is the index of refraction of water. It has to do with how fast light moves through water. We can find the index of refraction of any other substance by doing the same type of experiment. For any medium, the index of refraction is the ratio of the ratios of the triangles that light makes in air and in the medium. Our equation actually only works because the index of refraction of air is so close to 1. If you were going from water, say, to diamond, you would need both indexes of refraction in the equation. It's sort of hard to remember the equation with all of these ratios, so let's clean it up a bit. Let us rearrange the equation so that everything having to do with one medium is on one side and everything having to do with the other medium is on the other side. You can see now that the index of refraction times the ratio is equal to the index of refraction of the second medium times the ratio of the triangle light makes in the second medium. Trigonometry will not be discussed in this video, but the opposite to hypotenuse ratio is equal to the sine of the angle. So we can replace those ratios with sine of angle. This is the full version of the law of refraction. It is known as Snell's law in honor of Willibrord Snellius, I'm not kidding, who discovered it much later than 1984 when it was actually first published by the Persian scientist Ibn Sal. Let's now try a problem. A ray of light comes from air, index of refraction 1, into water, index of refraction 1.3. The angle of incidence is 20 degrees. Determine the angle of refraction. N1 sine angle 1 equals N2 sine angle 2. So I put in my numbers. 1 sine 20 equals 1.3 sine unknown. Then I solve the left-hand side just by plugging that into my calculator. Now I'm going to divide by 1.3 to get the sine x by itself, and then I'll take the inverse sine to get the angle. My angle is 15 degrees. Let's try the same problem in the other direction. If light starts in water, index of refraction is 1.3, and goes into air, n equals 1, and the angle of incidence is 15 degrees, what's the angle of refraction? My angle is 19.6 degrees. Notice that's close to 20. If you wanted to find the index of refraction of a mysterious substance, you can do that too. Light coming from air, n equals 1, enters a mysterious substance. The angle of incidence is 30 degrees and the angle of refraction is 15 degrees. What's the index of refraction of the mysterious substance? Our mystery n is 1.94.